Hi, my name is Tom Maxwell, President of Quip Corporation, and we're going to talk a little bit today about measuring dies. The die is an amazing, simple, and versatile tool that is the heart of the drawing process. However, it has its limitations. It cannot be expected to produce consistent wire quality with inconsistent die geometry, varying incoming wire diameters, poor cast and helix, improperly descaled rod. So what we're going to work on today is how do you quickly measure a die to see if it was a problem within the drawing process. To start, we're going to check the die's diameter. The fastest and easiest method to do this is with plug gauges. They're classified as comparison gauges since the size of the die is compared to the plug gauge to see if it passes through the die or not. So if I take a gauge and it passes through the die, it is at least the size of this gauge. And I will do that until I find the gauge that does not pass. The largest gauge that passes is then considered the size of the die. The accuracy of the die can then be measured in the steps from one gauge to the next. Typically, plug gauge sets have steps of either 1/2 of a thousandth or 1/1000th of an inch, or 0.01 to 0.02 millimeter. Since plug gauges don't measure, it is not possible to determine where the size is in between the steps. They are a go, no-go gauge. If you try to put the gauge in and feel by wiggling it, you are still not making a measurement. The best method to make sure the die has the correct approach angle is to use angle plug gauges. Like a plug gauge to measure the diameter, these are also comparison gauges. Simply insert a gauge into the die, apply a small amount of downward pressure and see if it moves from side to side or locks in place. If there is movement from the bottom of the die angle, the angle is narrower than the gauge, and the opposite is true if there's movement at the top of the die. Next, try the next smaller gauge or larger gauge to see if it fits into the angle better. If there is movement at the top and bottom, the approach angle is not true and is a radius. A die does not need to have a bearing to draw wire. However, to produce wire for any length of time at a consistent size, a length of parallel bearing is needed. The bearing length is expressed as a percentage of the diameter. For example, a 0.250 inch or 6.35 millimeter die diameter with a 35% bearing length will have a physical length of 0.88 inch or 2.22 millimeter. Since it is very difficult to measure this length without expensive equipment, dies should be made with the meeting point system to produce better dies with the correct bearing length. It is very difficult to determine the length of a bearing by eye with holding it up to the light. The best way to make sure a bearing is within tolerance on the shop floor in the die shop is to calculate the minimum and maximum bearing length by multiplying the die's diameter by the bearing percentage, then get plug gauges that are the size of the minimum and maximum length of bearing. We're then going to hold them up to the back angle and compare the length of these gauges to the length of the bearing. If you have a difficult time seeing where the bearing starts, we can take a gauge that does not pass through the die to indicate where the bearing starts. This again is a comparison measurement, but works well to give your eye something to compare to prevent excessively short or long bearings that will cause drawing problems. Dies are most often judged by a visual inspection of how shiny they are. This can be very misleading because a shiny surface does not indicate how well a die will work. What is important is the surface finish or how flat the surface is. The reason for this is any surface wave or roughness, even highly polished, will cause the wire to travel over a longer distance and create increased friction. This is not to say the shine does not matter, but is secondary to flatness. As the surface becomes flatter during manufacturing of the die, the shine will come out on its own. A shiny surface is more important in drawing non-ferrous, stainless steels, or in high-speed drawing to prevent galling. To check the surface flatness, look past the shine for any cutting marks, wear rings that have been polished over. The easiest way to do this is to look into a fluorescent light and get the light traveling through the die. Look at the edge of the die. If it is jagged or wavy, so is the surface of the die. This can be done with or without an eye loop, depending on the size of the die. So as you can see, we can do a couple very quick measurements to tell if a die is in tolerance or out of tolerance, and is that what caused the process problem. If you check the die and none of these things are out of tolerance, the die should not be blamed for the drawing problem, and what should happen is all of the different process controls on the machine, block alignment, the scaling, drafting schedule, should all be checked to make sure that they didn't cause the die to fail. The die is your process gauge. If they're made consistently, you will produce consistent quality wire. When your process goes out of tolerance, it will cause the die to fail prematurely. So I would not blame the die first, I would check process first after doing a quick check on the die to make sure it is correct.
Now let's review some key points from the video.